Okay, so as part of 4152's programming textbook that's in production right now, we wanted to give you a more comprehensive insight as to how to use the TalonFX configuration class for your TalonFX motors. So one of the more confusing things about this is all of the slot zero configurations and how to set them up, as well as all the other variables that you usually find in a constants file. So I'm going to break down in this video what each variable represents, and then in the next video, which will be in the same playlist as this one, we will go through how to assign all of your variables and how to get all of your values using TunerX. So just to start by breaking things down, we house all of the TalonFX configuration variables in an IntakeConstants file. The structure of this usually goes under a constants folder in parallel with the subsystems and commands folder. So getting into it, our first variable would be just your gear ratio on your motor. You can use this in a few different places. In the feedback configurations, we're going to use that down here. So with that being said, for the most part, a lot of this stuff I would recommend copy pasting. In our textbook, you'll find a link to this exact set of code. The advantage of copy pasting this is that all of these values are basically, you are able to change all of them. So like you would only need to change the gearbox ratio and the home position for whatever your mechanism needs, but everything else is basically set to default values. So 0, for example, you would change that to whatever you would need, and we'll get into how to do that in the next video. So after the rotation gear ratio, you'll see we have the rotation slot 0 configurations. So these are the primary values that we're going to be looking at how to get. The first one I want to talk about is the gravity type. So what you'll have to do when you're making your mechanism is determine what kind of mechanism it is. So the gravity type right now for us is arm cosine. We have an over-the-bumper intake, which means we're rotating, which means the gravity is changing as the force of gravity is changing as the mechanism moves. So you would use the arm cosine gravity type. However, if you hover over it, you can see that there's an option for the elevator static for more straight up and down elevator systems. So if the force of gravity won't change over the course of the rotation, then you would rather use that value. After that, we have the voltage needed to overcome gravity, as well as the voltage needed to overcome static friction. In the next video, I will talk about how to get those. And then after that, we will have the velocity and acceleration values, same thing. Finally, your PID values. We will only be using P. We won't use the I and D values. For us, it's just a bit needlessly complex. But if you feel those would be important, there's other resources on how to obtain those values accurately. There's many different ways to get your PID values and how to determine them, and I'll show you a system on how we do ours. After this again is something unique to your system. What your current limits are, your voltage configurations. We have our set to 20. Make sure this variable is true so that it'll be applied. After that, your feedback configurations shouldn't change. If you're using like a Falcon motor, you'll just have this value here, and then you'll plug in your gear ratio into the sensor to mechanism ratio. When you deploy this code in TunerX, all of these values will get automatically sent over, which is why it's nice to put all this in the code here, so you don't have to manually change it each time. Down here is the motion magic. If the motion magic is something you would look at using, that's fine, but for this purpose of this video, we're just going to stick to the slot 0 configurations because those kind of get you up and running. The motion magic is a bit more complicated, and you can experiment with that at your own pleasure. And finally, the software limit switches and configurations. These, again, are very specific to your mechanism. Essentially, I'm not going to show you how exactly to get these, but essentially you're just looking to plot the location of your motor and just get that value. And if you don't want it to exceed that, you would just plug those in and set the variable equal to true. So if you have an elevator, for example, that could extend past the allowed perimeter, then you could set a software limit on it to prevent it from going outside the perimeter. After this is an optional variable. You can use it in the subsystem, which I'll talk about in a second, but you can set a home position to basically kind of set your default location or whatever. It's used as an offset in most scenarios. So to quickly jump over to the subsystem, where would we use this stuff? Well, it's all applied to the motor automatically. And it does so by creating an object of the TalonFXConfiguration class, and then assigning all of this stuff. So it assigns its variables to the intake constants with all the values you've set. So what I've done is I've just created a method to assign all the values and called that method in the intake constructor, so that when it runs, it creates the TalonFX motor and automatically applies everything. That is all you would have to do. From there, I'll show you in a future video on how to actually control the motor. You'll probably do something called the voltage request. But for now, that is the baseline of all of it. So if you get all of this code in, the next video will show you how to change the necessary values to what you need. It will involve you will need your robot with driver station, and you'll need Talon Tuner X installed.